All right, we are recording. So good morning, everybody. Thanks for joining us for this Pro2Pro webinar. My name is Holly Champion, and I'm the Senior Director of Communications and Programming for the Colorado PGA. Just a couple of housekeeping items before we get started. First, please mute yourself if you're not speaking. This is not a webinar platform, so I can't, you can speak at any time you want, but I would ask you to just mute yourself for background mitigation. If you have a question, you can do a couple different things. You can use the hand raise button if you'd like to ask it in person or be called on, or you can also type it into the chat at the bottom. I will be moderating some of those and help Steve work through questions as we go. He'll also open up for a few minutes at the end for more questions Q&A session. And this will be recorded and available in the members only area of the Colorado PGA website in case you'd like to reference the content in the future. You can also pass the link on if any of your coworkers weren't able to make it today. We can make that available on the website for them as well. So at this time, it's my pleasure to introduce PGA professional Steve Atherton. He's the director of golf sports medicine, the golf sports medicine program at the Steadman Philippon Research Institute in Vail, and is a 24-year PGA professional and member of the Colorado section. So at this time, Steve, feel free to take it away.
Thank you, Holly. I appreciate it, and thanks to all of you for getting on the meeting here this morning. I hope to provide at least a couple pieces of information that will be helpful for you with teaching, or maybe looking at some students that have a few unique physical challenges, things like that you might run into. I'll start going through. I've got a little PowerPoint, just a few things to show you how our lab works here. I work in a hospital in Vail. I work inside of a biomotion lab that has a lot of cool technology in it, not just for teaching golf, but also for analyzing human movement. And I want to show you some of the technology that we have and how it works. And then go through maybe a few golf swings, talk through some stuff that you might see with people, and hopefully it'll be somewhat valuable for you. So I'm going to start with the PowerPoint here. Couple little things, background about myself. I'm a PGA Master Professional in Instruction. I went through that program in 2005 and got certification then when I was working with Golf Tech, and was Vice President of Instruction for Golf Tech for about 11 years. I used to train all of their teaching professionals how to teach. So we did Golf Tech University. It was a 10-day training program where they would come to Denver and learn how to analyze swings using technology. Essentially, I started teaching golf in 2000 and have been teaching with technology ever since. So I've always had, video systems, motion capture systems, flight scopes, foresights, almost every type of ball flight device you can imagine. I've probably tried it or used it at some point. So I've always taught with technology. Feel like it's helped me tremendously in my career. And then I was the teaching professional at Eagle Springs Golf Club out in Walcott for 10 years, and was inside of a nice building with a flight scope and video system. Wonderful membership there. And then I got a really unique opportunity here in Vail to come into the hospital and work for the Steadman Philippon Research Institute, which I've been doing now for about 3 years. The golf sports medicine program here is, we are quite sure, the first of its kind. It's essentially a program that's designed to help players get back after injury. So if somebody goes through needs a new knee, a new hip, or gets shoulder surgery, etc., I work with those golfers, and it can be any level of golfer. We have PGA Tour players come through here. We have people who are 80 years old and shoot 100 come through here, but they're always avid golfers. And so the surgeons upstairs know that if they've got somebody who on their intake form say, yeah, I really want to get back to playing golf, they generally send them down to me, and then I help them with their swing and with their motion to make sure that they either are not hurting themselves any worse with their swing or causing problems with the new hip or the new knee or the repair. And also just making sure that we're easing back into golf the right way, so I can help them kind of work through some of the issues they might have and build a better swing and build it slowly so that they don't go out too fast and hurt themselves. And one of the best things about the program here is that I collaborate really closely with their surgeon or their doctor and their PT. So right across the hallway here outside this glass is Howard Head Physical Therapy. And then right upstairs is the Stedman Clinic, where they have, talk to their surgeons and have their body issues repaired. So when they send me somebody, as I was at Eagle Springs, maybe somebody would say, hey, I'm working with a physical trainer in Avon or Edwards. And I would say, okay, well, tell them that you're trying to do this in your golf swing and then work on this with your hamstrings, etc. Here, everything's in-house. So the doctor may come down, especially if it's a VIP or high-end client. I'll have the PT come over. We'll look at the swing together. Or I'll say, hey, what are they cleared to do? How much can we push? What types of things can we work on in the swing, or how far along are they after surgery? What limitations might we see in how they move yet? And then that way it's a really good collaboration where we're all working together to help the person improve in the most efficient way possible and in the safest way possible for their golf game. The whole thing here, I will say the Stedman Clinic and Stedman Philippon Research Institute, their goals are to help people live longer and live healthier and enjoy what they want to do. So one of the things that I really, really appreciate here, because it's a world-class orthopedic facility, I'm from the Midwest. If I went into a doctor, typically where I'm from, and I say, hey, I got a bad hip, they would x-ray it, they'd MRI it, they'd look at it and they go, this is what's wrong with your hip, and this is how we fix that. Here, they have a little different approach. They work with so many athletes. The Stedman Clinic goes, and Dr. Philippon did my hip in November. I had some work done on my hip, and he said, what do you want to do? And when they ask you that, and you say, well, I want to play softball and volleyball and run around and jump and do things that I've always done, then he goes, well, then you don't fit this category. We're going to try to work on your hip this way because I want to get you back to that, which is a really refreshing and great outlook on how to help people. So they say, look, you want to get back to playing golf? Here's how we're going to do it. We're going to have you go see Steve. We're going to fix you this way. And that's going to be the program that you're on. And then within the program here, I can teach anyone. They don't have to be a patient. It is ultimately a pay-for-service program here. So if someone just wants to come in and take a unique golf lesson and have a golf experience in the lab, they can absolutely pay to do that. It's not a problem at all. So I teach patients, but I also teach everyday golfers that just want a unique golf lesson. And as I said, I teach in a biomotion lab. We're going to go through, I'm going to kind of list these out, and then I'll wander around the room here and just sort of show you how some of these things work. But of course, I have basic video systems. So I've got V1 video and a GC quad launch monitor with sim setup for the golf side underneath the mat here. So here's the hitting mat, and you can see these little rectangles there in the floor here are Bertec force plates. There are 4 of them underneath the floor. And then we also have a Bertec instrumented treadmill, which I'll show you in a second, that people can walk on, do gait analysis. We have stairs that we put on the treadmill so that we can see how much pressure they put in each leg as they walk upstairs for maybe an ACL or a knee injury, things like that. We have Naraxon EMG and IMU system. IMU is inertial measurement unit, which is essentially a fancy way of saying a gyroscope and an accelerometer all in one little piece. So like an Apple Watch, it knows how many steps you take by how your arm swings. Well, picture taking 16 Apple Watches and putting them all over your body. You could use those to measure movement outdoors. So we'll talk about that in a minute. And then EMG is electromyography. So the same sensors also have little electrodes on the back of them. So if you put them on a surface muscle on the skin, you could actually tell when the brain is signaling that muscle to turn on or off, which could be a really fun way to start to analyze maybe the golf swing. So picture if you put a surface marker on your glute and one on your tricep, bicep, maybe one on your somewhere on the shoulder, on the muscles that are close to the surface, and then you could look at when the body is being told to fire and which muscle your brain said to go first, and maybe we could look at sequencing through those. They're really cool. There's some other things they do as well. We'll show you here in a minute. Then I have a Qualisys markered motion capture system. So as you look around the room of the lab here, there are a bunch of cameras up in the ceiling. Here's one there. So these are there are 19 cameras around this room. If I can get this to point up and look decently. I'm sorry, I'm using my laptop here as a microphone too. But that Qualisys system, those 19 cameras are about $10,000 a piece. They do markered capture. So you wear these little glass reflective balls, just like if you've ever seen how they do animations for movies. You put a person in a skin tight suit, you put reflectors all over them, and then those cameras track those motions within the room to about a millimeter. They're really, really accurate. They're kind of the gold standard for research. So when we do research studies on anything, not just golf, we use the Qualisys system to measure. And then we have a dynamic stereo X-ray system, which is probably the highlight of this lab. I will show that to you in a minute, but it's essentially these towers and all these pieces over here. This is a dynamic X-ray. So what that means is you look at X-ray like a video. So it will do up to, I believe, about 200 X-rays a second. And Dr. Tashman, Scott Tashman, who's the head of biomedical engineering here, built it. He designed it himself and built it. He is a electrical engineer, mechanical engineer, and knows medical very, very well. So if you ask him how, cartilage forms, he spits off an answer. If you say, how do you design an X-ray? He's going to go, well, there's a tungsten plate that fires off X-rays and does this, and it veers into this, and that cathode tube pulls this, and it's like he knows how to build all of it. It's really wild how smart he is. So I'll show you a little demonstration of what that thing does in a minute, but it's incredible. And then we have a Dari 8-camera markerless motion capture. Is a really, really phenomenal way to analyze golf swing movement, but other things as well. And I'll give you a demonstration of that here in a second. So this is a picture of the main lab. I mean, you'll see it here in the video. You can see there the golf sim setup. We've got curtains that slide back, so it's all modular. The mats can be pushed up and rolled up to the edge so that if we do research studies within the whole lab or need people to walk back and forth, it's easy to undo. You can actually see just peeking out from under the golf mat there is the edge of one of the, I don't know if you can see. Oh yeah, you can see it in there. Right there. So there's a Burtec force plate there. There's another one right about here. And then there are two underneath the floor where the golfer would stand. So we have 4 of them. They're about $10,000 a piece. So if you've ever seen like a swing catalyst or one of those type of floor mats that are $2,500, $1,500, these are really, really high tech and accurate force plates. And so they will also do torque, so twisting force as well as downward force and shear forces. We've used them recently for a golf shoe study. So I've had this idea that, Dr. Mark Philippon here is one who's worked with probably 50 to 75 tour players. He's repaired a number of hips on tour. The majority of them are the lead hip, of course, because we're all firing into this lead hip really aggressively, and it puts a lot of strain. And that's exactly what went wrong with mine, and had to have a labrum repair and some femur issues fixed and stuff like that. So the spiked golf shoe, it creates a lot of grip in the floor. And then when you watch people like Scotty Scheffler or, most of the women golfers, as they turn into impact, the shoe will twist and move and rotate and different things. And I think that's a brain response to the forces they're putting in the ground, but also like I need to create some relief in that lead side or I'm going to tear my knee or my hip up. Because if you had a fairly square left foot and turned aggressively into it with spikes and the shoe doesn't give, it puts a ton of stress on the knee. Now that also provides a component of like efficiency in a golf swing. We need that grip and that braking force to swing well, but we also want to try to design it where it doesn't blow your knee out, or your hip. So we've tested on those force plates golfers wearing tennis shoes that are very flat bottom, like just a basic tennis sneaker, and then some golf shoes with spikes on them to see how much the forces increase. And the data's been okay, not actually as much as I thought it would. But anyway, we use things like that to analyze motions and weight shifts and things like that. And then, of course, I have a GC quad launch monitor. We'll probably look at some data of that here in a little bit, but hopefully everybody's seen one of those, or at least knows some of the data that shows up when you hit balls off of those things. And then I think it should move to the next one here. Oh, there we go. And then this is looking the other direction in the lab. So that shows the Burtec treadmill, the instrumented treadmill. Let's see, I think if I that. Hopefully that didn't kill my microphone. I don't believe it did, but so the Burtec treadmill and the stairs there in the background on the left, that we use those two things to analyze like ACL recoveries. And the treadmill was $150,000, I believe. It's all instrumented into the floor, built down underneath. There's about a 5-foot deep well underneath it with load cells. And you can do gait analysis on it. You can actually set it up to do random judders to look at how people react to slip and fall situations and see if they can catch themselves when they slip. It's a pretty wild piece of machinery. It can go, I don't know, 20 some miles an hour, and it's 2 belts, so we have 1 for each foot. And then the Naraxon technology. Let's see. I'll grab one of them here. So the Naraxon system, as you'll see here, so there are 16 of these little sensors. And so this is the EMG side, where we have the electrodes that would go on the body. And then these little guys have also a clip on the top, which you can use to connect other devices. So we have, for example, we did a ski boot study. We took some, I don't see one sitting out, but we take footbeds and put them inside of the ski boot, and we can see exactly where people's weight is as they ski. And I'll show you, I think one of these has, let me see, this one. Well, I'll come back to that in 1 second, but if I play this video, you'll see you can see the graph in the background there takes off when she flexes the bicep, and that's the brain essentially sending an electrical signal to the bicep to kick on. And so you could have 10 of those on you at one time and have somebody go out in the let's see, the next slide here. There we go. You could have someone go outside and run or ski and get all their joint angle data as they do it. And you could have things put in the boots. Let's see. Kind of likes to go once in a while. There we go. So these are the footbeds. So you can see as this person is walking, as you're kind of watching this motion. Let me see if I can pause it and slow it down a little bit. I think it'll let me. Yep. Okay. So as this person hits, you can see they roll to their right big toe. And then as they hit in the left foot, it's a really heavy left heel hit. And then they roll to the outside edge of the left foot. And so that, just watching that cycle every time, you can imagine if you walked that way all day long and you were on the inside edge of your right foot and on the outside edge of your left foot walking like this, what it would do to your hips, your knees, your back. This was something, this one isn't me, but I had a very similar issue when my hip was starting to get bad. And you could do soft tissue work to help that. You can obviously have a surgical procedure to take care of the imbalance or the issue that's causing it. But that allows us to measure and look at those patterns as somebody's walking or skiing or what have you. So it's a really cool system to be able to understand how people are using their feet and using the ground. Come on, go to the next one. There we go. And then this is the Qualisys system. So this is actually a person hitting a baseball. Play. Go back. No, it doesn't like those videos, but it's not a big deal. You can see the the markers. So on the left side, every one of those little dots is a marker that the Qualisys system is seeing. And then on the right side, it is a 3D mapped version of that swing on the left. So we can use Visual 3D to create a skeleton of the person and then see all the forces in the floor. So they're standing on those couple of those force plates as they swing at a ball on a baseball tee, and we can see all the dynamics of how the body's moving, where the weight goes. And if that video played on the right, when that person's left foot hits the ground, you see a really aggressive vector go straight through the left hip and all the way out to like here. So the baseball swing takes a lot of force again into that lead hip. So baseball players, pitchers, golfers, hockey players all tend to have some lead hip issues after a bit of time. So this next one, go to it. Come on. It's either my battery on my keyboard is getting slow or something here. There we go. So this is the same thing for a golf swing. This is actually Harris English. Came in here for a right hip issue, and you can see, so there on the left is the Qualisys video of his motion. I'll show you actually his swing on the actual computer here in a second. And then again, once his swing's been modeled into Visual 3D, you can see the whole movement. And he had a bad right hip. He came in and said he was playing in Hawaii and he was hitting the ball like 240 yards, like he just lost all power, and his right side couldn't push or do anything. So he came in and got to measure his swing and look at some things he was doing. But and then this is the dynamic stereo x-ray system. So this is a person with the system set up on the treadmill. So we have a couple different things. So you have two panels here, and then x-ray generators here that are shooting through the knee into that panel, and then back here on the right shooting through into the panel. And so what we get from the x-ray board here is something that looks like this. So this is this one's got to play. Well, I can play it on the other one if it doesn't, but this one played earlier, but come on. I can see the video in the background. Let me try one more time here. You know what? I'll go show you that on the other computer. I think when I converted my PowerPoint from Keynote in Mac to PowerPoint, it didn't like some of those things, because this one should play and it shows joint spacing. You know what? Actually, while we're right here, I'll bring it over here and do it on this one, because I know it'll work on this one. The same videos anyways. All right, so I'm going to get this where you guys can see this screen. And this is the dynamic x-ray. So this is a jump landing, essentially, in 120 images a second. So you can see the bones interact. You can see the x-ray in motion, which is pretty crazy. We only use it for research studies, and then you can actually see here the person, it's an ACL recovery, because there's a screw here and a screw here holding the ACL in place. And then the other video I was going to show you on there is this one, which is the joint spacing. So once we take that 3D x-ray, then we can model each person's movement and see the spacing within the joint as they move. And we can also use it then to look at things like ligament elongation, like this one here in the bottom right. You can see that if you have the model and you know where the insertion points are on the knee at the bottom of the femur and the tibial plateau, then you can see how much stretch there would be in a ligament when they move. So that's that. All right. Sorry, didn't quite work on the PowerPoint the way I wanted, but. And then we have the Dari markerless mocap system. So this one I'm going to show you here, and I get this set up. There we go. Okay, so this is an 8-camera system. So you can see as I move around the room, there's several different camera views to watch this, but I'll do one from this view. And I'm going to go out here and have it acquire me as a skeleton, and you'll see what it can do. But essentially, it's an 8-camera system. You know how there's a lot of the new sports box AI, and there's a few iPhone-based motion capture systems out there. But of course, you're only getting, like, I know Golf Tech has moved to a motion system that's all done through camera, but they have 2. And 2 cameras is unfortunately quite limited. It's very hard to get really good data from just 2 views of a person. You can't hardly get 3-dimensional data from 2 views. So this one, because it has 8 and the way they use their software is really good. So all I have to do with this one, instead of the Qualis system where you have to put the person in the suit and put a bunch of sticker tape all over them and put reflectors everywhere, this one I simply do this. I hit acquire skeleton, and I'm going to walk out in the bay here real quick. Do a quick little calibration move, just this little move here, and then it should latch on to me. And now this thing is mapped out everything that I do in the room. I can do squats, I can do jumps, I can make golf swings on it, and it knows my hip turn, my everything that I do. And so when we use that system, what we get are things like this. So if I go here and I look at a report like this gentleman right here is a guy named Tyler McCumber. He plays on tour. We may look at his swing here in a little bit. His dad was Mark McCumber, who obviously played on tour for years. Tyler has had a few injuries that he's coming back from, and phenomenally good golf swing, hits the ball incredibly hard. And so we can look at things like his trunk data. We can go see like his separation, how much he's rotating. So like if I click down in here, we'll see backswing, hip rotation with the system right at about 38 degrees, and shoulder turn about 105. So huge X factor. You can see with these graphs, like the steepness of this graph. So how vertical this is going here is how fast the hips are rotating as he comes into impact, and he gets to the hitting position right about there, roughly 51 degrees open hips, and I can see that from different angles. Tanner who's on the call will know. I've played out at Frost Creek with him after shoulder surgery and after his first hip surgery, before he was getting ready to go back on tour. And he hits it about 370 out here with a high cut. And I think I played twice with him. The second time he's coming back from the third right hip surgery, and he might have missed 2 shots the entire day. I've watched a lot of, I've seen Tiger in person close up, Rory in person, Adam Scott in person close up. He hits it as good as anybody I've ever seen. It's pretty wild. And you watch some of that data and how he moves, and you're like, oh, I can see how he generates so much power. So, but then the other cool thing about Dari, if I bring it back around, is we can also use it to do functional assessments. So if I go back here, we also have all these different protocols. So like if I do, for example, let me grab one of these who's done a let's see, athleticism test. So these tests, if you have somebody go out there and do vertical jump and do some lunges and do some squats, and it'll tell you their athleticism level. So you get these really cool reports on how people are moving. And so you can see athleticism. You can see their explosiveness. You can get all of the data of how they move. Your vertical jump was this, your squat depth was this, your joints, how they move. So this person had, left knee working great, right knee not quite as good, left shoulder working great, right shoulder not as good. And I think if this is the person I think it was, this was a group of military top officers that came through, and he had basically parachuted out of a helicopter, and one of his buddies hit him about 200 feet above the ground. Like they were both parachuting and they collided, and he fell 200 feet. And so his whole right side was a big, humongous mess. But and actually still moved incredibly well after lots and lots and lots of rehab. And they do that here at the hospital with them, and do a couple weeks of like intense training and stuff, which was really helpful for them. But you can also see joint reviews, so like how all the joints are moving throughout all the testing. You can see sub scores of like mobility versus kinetics, things like that. And then the last one that's kind of fun is if you do certain tests. Let me see if I can grab some here. Let's see, like this one maybe. You can see a motion age. So there are a few tests you can do, and it will tell you how old you move. So this woman she's 56, but she's moving like she's 18, which we see quite a bit up here in Vail, because we got a lot of really healthy people that are, into their 40s, 50s, 60s, 70s, and aging very well and very active. But, so it's a kind of a nice baseline you can set where you can see your motion age and go, well, let me just come in, get a quick test, and see how old I'm moving. And it can be a little humbling at times, but it also gives you a nice baseline that you could send to your, PT or your trainer to, move forward and say, all right, I want to go a couple months, do these different exercises. The system showed that my right shoulder wasn't working so hot, so I want to definitely do some work on that, and then come back in and take another test and see how much you've improved and where things have gotten better. Motion age athleticism testing. Okay, so all of this technology that we have here in the lab is amazing. I tell people all the time, I think that we can measure most anything people would do in here except the brain. We don't have a way to figure that out just exactly yet, which I think once we do that, I'm going to be a multi-millionaire, because the brain is the one thing with that golf ball sitting there that is still a bit of an unknown. I mean, we just don't know why, when I can get people to make motions that are 100% good for golf swings, and then you put the ball in front of them and the swing changes a lot, and it's 90% of the golfers. I mean, in fact, I think that the tour players probably do the best job of replicating a practice motion with a real motion, or close. And I'd say average to not very good golfers, their motions, I can get them to make swings that look really, really good, and all the hips are rotating the right way. All these things are working. But as soon as the ball goes down and they know they're going to propel the ball, muscles get tighter, things get out of sequence. It's pretty wild what the ball controls in your brain. So I'd love to be able to figure that out, but we can measure about everything else in here. So then it comes down to like, how do I use it to help people? And there are a number of different ways, but initially I talk with their surgeon and their PT. Of course, I go through like, what are they capable of doing? What's the limitation? How far can we push at this point? Then it depends a little bit on the injury or the swing issue. So, for example, like if I have a person who has a hip or knee issue, then I use the video and I use the force plates a lot more. If I have a person who has a shoulder injury, well, then I look a lot more at the Dari system to look at rotations of the shoulder, and I look at the video again just to see what's happening. So knees and hips, we use the force plates. Back, I use Dari again to see. I want to make sure, like, as I look at back issues, the thing that I've seen the most in here is that when people have a back problem, generally their instincts and their brain tells them to not move. And so they get very stiff and they swing and they try to use their arms, but they still try to hit the thing. And so it's actually bad on your back because you're holding still here and holding still here, but you're trying to use your arms to propel the ball out, and your arms are flinging this way while your back's trying to hold tight, and it yanks on everything back here. So I use the Dari mocap system to actually try to get the hips and the shoulders to move as a unit and synchronize those a bit so we get some size to the swing that doesn't create stresses and twists. Shoulder, hand, and wrist, mostly video stuff. So just looking at the video. And then if I'm working with somebody who's an uninjured golfer, just somebody who comes in and says, I just want to get a better golf swing. To me, I use GC quad data first. I look at what the golf club is doing, how it's interacting with the turf, what path is it on, what's the face doing, where are they hitting it on the club face, and then I look at the video system and I say, well, why are you doing that? Like, what's causing you to make those movements? So here are some things that I just look for generally. This is more like golf swing 101 stuff that I've just looked at over the years. And as I've used some of this technology to kind of understand how people are moving, these are things that I see a lot that I think every golf pro can do, whether they've got a bunch of technology or a little bit of technology. But there's some important ones, I think. So one of the first ones to me for sure is ball position and head position relative to the golf ball. The more I have watched good players, the general theme is that they play the ball quite a bit more forward than the average golfer, and even some well above average golfers. But the golf is a very much a spatial endeavor, and so when people have the ball placed in the wrong spot or they have their head too far in the wrong place relative to that ball, it changes everything that they do dynamically through the golf ball. So I'm going to go to the video here and look at a swing of a guy who just came in here not too long ago. Let's see if I can get stuff out of the way here a little bit. All right. So if I go here and let me bring up Adam. So this gentleman came in last week. He is very, very accomplished amateur player and has won a number of things, plays senior stuff now. So 39,667. Let me find this. Can't see these numbers very well anymore. Should be about in here somewhere. Should be some of his first swings. There. So there's a 7-iron out of the gate. And you can see that if I, for example, if I put up next to him somebody like Adam Scott, who I was in the room here watching him hit some golf balls in at Queenwood, which is in London. This is his. So there's a 6-iron for Adam Scott and a 6-iron for Adam. Now this guy is probably a +2, but you'll notice if I draw a line up from the golf ball, his entire head is in front of the ball, and Adam's entire head is behind the ball. And when we get to impact, his head's still mostly in front, and you can probably guess what kind of release he's going to have. It's going to be very scoopy. So his left arm and club shaft are not even in line anymore, and it was barely past impact. So I always look for where does the left arm and the shaft of the club go in line with each other. And I'd say his is right there, about a foot before the ball. By there, definitely club shaft starting to pass the left arm. Well, he does that because he's trying to hit a 7-iron up in the air. He knows the trajectory that he wants to hit an iron, but he's moved himself so far forward of the ball, and the ball is so far back that essentially the only way he really can get height on this golf ball is to flip it and throw it up in the air. So then he loses power. Most of you probably know if you play the ball more back in the stance, you tend to get a path that's more in to out. He was 4 to 5 degrees in to out almost every swing, and he didn't like left. So I said, well, you can't flip that much with your hands and not miss left sometimes, like especially when your path's in to out 4 or 5 degrees. that path is going to create more blocks and more ropey kind of overturned hooks. They also don't hold the green really well. And he said, I'm really struggling with my pitching and chipping. And of course, he's playing the ball in the same place, hitting a 30-yard pitch shot. He goes, I almost get the yips. And I'm like, well, no kidding. You got the ball back way too far and you're flipping and throwing the thing. So this is a guy who's won multiple like national amateur events and things, and he can't hit a 30-yard pitch shot because of his ball placement. You look at Adam and you go up to the top of the swing, and I show people all the time, I go, if you go from the middle of his eyes straight down there and then go over to the ball, I mean, his eyes are 5 or 6 inches behind the golf ball when he's at the top of the swing. So his natural movement pattern then is going to be to move forward, get a really nice good weight shift into that lead leg, and then left arm and club shaft are not going to line up with each other until just past impact. So this is the spot we want to be having those things line up. And I think part of that starts happening with golfers because of ball position. And you can see it. I think part of it stems from driver lofts, like guys who have too low of a loft of driver, and then you throw a little back ball position in, and all of a sudden we're throwing it up in the air. So I tried to get Adam to make some of those changes, and we were able to use this device I have here. It's called a Swing Right training aid, and I use it a bunch. Let's see if I can find where he was using it here. It's right in here somewhere. That was some one-handed work we did, and there. So this is a clicker device. I'll show it to you right here. It's very simple. It's a stick with a screw down spring in it and a collar that snaps when you release the club, and you can make it go a little harder, a little softer. And that clicker, I said, I want you to rotate your hips. I want you to keep your right wrist cocked as long as you can, and I want you to delay how you hit this club. Oh, that's not the clicker. Hold on. Thought it was. It's right in here somewhere. What is the numbers on this here? 1,539,667. There we go. So he's working on a little bit of a squat, little sit down, move to his left, and keep right wrist waiting until here. And so then we get a pretty similar looking release pattern. He could hear it audibly click at that spot. And so it works really well to start building release patterns that you want. And that sort of leads to the next position that I look for a lot, which is hip and body rotation through impact, because when they don't rotate, the hands take over way more. And I think that is a really missed component of golf swings from teaching professionals. Like, I hear so much discussion about what the hands and arms are doing. And you hear tour players a lot say, oh, I'm keeping my arms in front of my body better and stuff like that. But they're also rotating usually 40-ish degrees at impact. And so golfers who don't rotate well through the ball, now when I'm talking hip turn, I'm saying through impact, arm patterns are really, they really suffer. So if I go to a player like this, some of you out there may or may not know this gentleman, but this is a guy who comes in here a lot, and we work on his swing. And when he swings the golf club, when I've had him on the, this is a really good hip rotation for him. This is like a 45, 50 degree hip rotation. But even there, his hips will be like maybe 5 degrees turned at point of contact. So let me pull up a side view of that here. When I've measured him on the Dari system, when he makes a normal golf swing, his hips are about -5 turned at point of contact. And so he keeps asking me, he goes, why do I struggle so much to get my arms to look better at impact? And I say, well, part of it is because you rotate back up to 70 degrees. I've seen him at times in the backswing. So some of his swings will get considerably more rotated in the backswing Let me see if I can grab one of these ones where he's turned a little more normal here. So yeah, he'll rotate way, way, way back, and then he won't turn through the ball, and then the arms will completely bunch up through the hitting area. So let me see. Oh, here's one right here. This would be a pretty normal swing for him. So hip turn really high, and then no hip turn through, and then a big pull into the arms through the hitting area. And he hates the way his arms look after impact every time we work on it. And I say, well, you can't turn 70 back and only 5 through, and you're going to pull your back, you're going to pull on your shoulders. And so rotation through the golf ball is a huge, huge thing to get people to improve arm positions after the golf ball. But it's hard because they're trying to swing in to out. So see, he was trying to get the club down and in, but his mechanism to do that is to not rotate the body at all. So once he does that, then he's already hitting the golf ball, and I can still see the top of his left leg here. So he's got no rotation, and then the arms just will pull through generally, and I'll see usually left elbow will pop out well before the golf club comes out. There's one. There's a good chicken wing right there coming through, and that just really puts a lot of strain on the back and the body. Okay, so then another one I look at is P6 club face position and club face. So that one is where you watch these model swings as they're coming down towards impact. I look at where is the club shaft relative to the hands and where is the face of the club relative to square. And the biggest issue that I tend to see here, well, this position absolutely affects release pattern on the other side every time. So if you have a person who has the face way too open, let me see if I can grab one right here. I know I had a guy in here just the other day that was doing this exact thing. I think it was one of these, maybe right in here. I know we'll see. Oh, he's got some videos in here. Hold on. Right there. So he's got the club lightly inside. He swings in out a little bit. He does not use his legs nearly enough. I get on him every time he comes in and say, you got to turn your hips when you're working on it. So this guy's a 6 handicap, but his club face is laid back at an angle about 10 degrees from 90. So he's about 80 degrees open here, like from 90. And you see McCumber here that I was talking about earlier, his club face is leaned forward about 11 degrees. So that's a 20-degree difference in club face position. The guy on the right hit this ball really straight. He does typically play a cut, but when he draws it, the club head would be just a little more in here. But he's rotated more and he's got the face square. This guy has to work hard to flip it or he hits it to the right. So we work on things like that, like getting the club into the right delivery position. I see so many people work on the face here, but see, that's not all that open at that point. I mean, maybe a tiny bit, but everybody watches the takeaway and where the club is, or maybe what it looks like up top, like where the face is sitting. I know his gets a little bit open at times. This one looks relatively square, but there were certain swings he would make throughout the day in here that they would get pretty open. And yet he's trying really hard to have like this flat left wrist up at the top of the swing. That one's better. And that face was at least more vertical as he comes down, but I still want him having more hip turn through the ball. So I always keep an eye on that position. And then hand path. So the path that the hands travel. So if I went back to this guy here real quick, and you look at his motion, I'll use the V1. I don't know how many of you guys look at V1, but you can already see like this thing goes back inward quite a bit. And then I use this tracking feature and I just start showing them from the halfway back position. I mark the middle of the hands. So he swings into out about 2 or 3 degrees most times, but his hand path is always a loop over the top. Now this was him just working a little drill to try to improve a little bit of that path. But when he doesn't have it, there's one where he's trying to take it back a little straighter. Then he can get it to come down a little bit better. And some of these swings, when he goes back to what he likes to do, the hands go so far in that he has like no choice from there but to loop the thing up and over. And so you can see that swing's changing a lot over time and different things. It still comes on a slight in to out path, but it's a huge over the top motion to get there. So we try to work on these things and balance the path, make sure it's, good players are tending to go more up and drop more in, and bad players tend to go too far in and go over. Let me see, Andrew, I just saw a question there. Let's see if I can see these here. Do you feel that from the top of the swing to that delivery position is mainly sequence dependent to get into good delivery position, or what makes the biggest difference from the top to delivery position regarding hands, club face? That's a really good question. I don't necessarily think it's a sequence issue. I think it usually is not having a good understanding of how to use the hands and arms correctly. So like when I've looked at motions of people over the years, one of the things that we look at in golf tech, we would see that shoulder tilt at the top of the swing was 36 degrees to the left, right? And by impact, they're 42 degrees right tilted this way. So you've got a split second to go from this way tilted quite a bit left to this way tilted right in a hurry. And golfers who struggle, especially if they put their hands a little on that inward path, want to start turning the body, and this shoulder doesn't know how to get down in the right position, and they don't transition this elbow very well. I had a kid yesterday that we worked only on the position of the right forearm at the top of the swing, and then initial downswing, we want to go to more external rotation. The problem with that is because a lot of golfers goes instantly into more internal rotation where this elbow falls behind the wrist, and you'd see that, and that starts over the top positions, things like that. But if you get them to externally rotate the arm the right way, so like if I go back to the computer and I go to one of my swings I use all the time in here is Fleetwood. He's got such a good, and he's a good draw swing player. We go up, and right there, top of swing, I'll measure that like from kind of center of elbow joint right up, try to get it right parallel up the form. So that's 69 degrees. And as soon as he starts forward there, that line has gotten more vertical by a little bit, right? It's 73 degrees now. So I want them to start to learn to do this. And of course, people who have bad shoulders or maybe have had a shoulder surgery, it's really hard for them to externally rotate an arm. So that it becomes an even bigger challenge because they want to get up here and be like this all the time. So we have to look at those things. But when you get them to externally rotate, generally the face of the club also falls open. So I think teaching them to learn to externally rotate the forearm, but get the club toe forward on the way down. So I spent a lot of time from right here coming down to that spot just with the arms at first to try to learn how to, the whole like motorcycle, like handlebar, like flex the left wrist a little bit and get that toe getting down into the right spot. That's how I usually do it. But it's hard because it's a lot going on at once. You're flipping shoulders from left to right tilted in a hurry. If you don't do that well, you're already starting to go over. If you don't get the forearm into the right place, that also hurts. And then if you can do that and get the forearm in the right place, the face tends to open. So there's a lot of hand and arm work that need to go in. And then they're doing all that and they don't turn their hips. So like you see all these things that these good players do that you're like, man, they're doing all that at one time. Like it's kind of hard to do it all. So I just work in pieces and get the arms working right. Then when I can finally get them down closer to waist high, then we start trying to build rotation. Real quick, I think I got one other spot I should have looked at. I went through a bunch of examples, but one other place I look for a lot of the time is when the club, basically P6-ish, when the club is, or when the front view, when the hands are coming by the right thigh. So if I go back to Tyler here, or go back to Adam Scott here, somebody like this, when you see these good players, I look at trail wrist position right there. So just as the hands get in front of the right leg, right there, these players almost always have right wrist pretty much fully cocked. And bad golfers absolutely do not. And even, like I say, sometimes players that are good who just struggle a little bit. So if I go back to like that guy earlier who was a good player that I had up, let's see, and go grab one of his first swings here. Doesn't really matter. All these look the same. So right wrist completely flat as the hands come by the right leg. He's already completely thrown all the energy out of that golf club. It's a huge reason why people can't, hit the ground early, hit it thin, because the, angle of attack starts to work upward when they do that. So it's such a scoop that they throw the club pass and flip it up in the air. So I look at that spot a lot, try to get some hip rotation and get right wrist coming by the right thigh, sitting like this. And I use that clicker device to do that a bunch. And then I look at the data, the motion data, sometimes the force plate data, if I want to see if they're shifting their weight into the lead leg as they do it, etc. So I know we're closing in on our hour here. I do want to open it up to some questions, because hopefully there'll be a few. Those are a few simple things I look for. There's about a million things I look for when I'm watching a swing, but I always just lead with GC quad data, see what it tells me. Then I go to the video and I say, well, why is it doing that? The examples were some of the people I already kind of looked at. We can talk through some of those, but anyway, happy to show other things if people have time. I've got time, but want to make sure I had some time for questions for any of you guys out there. If not, I can show one other example of the force plate data on the other computer real quick, or we can see if Holly, if anybody has a question, I can do that really fast. Let's see here. Let me pull this up really quickly. Let's go analysis.
Yeah, just a reminder, if you do have a question, you can either raise your hand and we can
I'll show you one
unmute you.
lady who came in with a pretty massive hip injury. Let's see. And let's see. Where's she at here? All right, so this is a lady named Louise. I'm going to show you the screen here in 1 second. So she came in, she had a really, really bad lead hip. 14. And there we go. Okay, so if I put this on here, you can see her, and hopefully you can see those little red force vector arrows. This is her first swing after hip surgery. And when I measured her at first, so first of all, when I measure tour players on here, their weight shift on the lead leg at impact with a 7-iron is usually about 80 to 85% on the front leg. And hers was 95% on her back leg, because her left hip hurt so bad and she just learned to swing that way. So I said, well, hey, go get your new hip, get rehabbed a bit, then come back in. Let's look at how you're moving. And the first swing, she went from 95% back leg to about 60. You can see her shift way off to the right, and then she kind of hangs on that back leg, and you can see the arrow here is considerably higher than the front leg. And I said, okay, that's encouraging. Like, things are moving in a good direction, even though we haven't worked on you at all yet. And then we got to a position think it'll pull this one up here, where after we just did some simple drills, and I did small things like, nope, it's not that swing though, hold on. This one. There we go. We did some simple things like putting a line of tape on the ground and telling her to hit the ground in front of the tape, like just athletically start to hit the ground over on this side closer to the left foot. And she went from, back foot hitting to she could actually, there you can start to see weight transition into the front leg by point of contact. Now her swing still needs a lot of work. She hit this dead straight off to the right. Her path isn't very good, so it's totally a toe shank. So we work on path, which I'm doing with those sticks on the ground up here, but she definitely still needs help with that part. However, her weight shift at least now is functional, and we can measure it and quantify it, and she can get to her lead foot and she could come through. And I said, I don't think you would ever fix your golf swing with your hip the way it was. Like it shows you very quickly how people's brains and how they adapt to what their body's showing them, and then how that affects how they move or do athletic motions or anything else. So, okay, well, that was an example I wanted to show you is how we use that Vertex system there to look at weight shift. Let's see, I think there might have been another one. Nope, just Andrew response. Any other questions or anything about the systems or swings? And as I've got my contact information up there, please, I always love to have PGA guys come in and guys and ladies come in and experience the lab, see what we do. Feel free to reach out to me there at that email or that's my phone number. Love to have you come in anytime. I'm always happy to show you around. I think that might be it. Holly?
Yep, I think so. Again, reach out to Steve if you have further questions, if you want to see his, I'm going to call it your candy land up there, because your technology is just amazing. But yeah, thank you so much, Steve, for doing this webinar this morning. This will be recorded. Usually takes a little while to render, but it should be on our website by the end of the week. And if you have any further questions, either reach out to Steve or myself. But thanks for attending today.
Thanks, Luke. Good to see you on there.
Thanks, Steve. We'll see you around.
Yeah. Thanks, Tanner. All right. Thanks, everybody. Appreciate you coming on.
Good stuff.
I think that's it. So, what's funny is I just realized that when I muted my